Now let's move on to how we actually measure air leakage in a vessel. And when I say vessel, what I'm talking about is either a home or ducts or any other type of vessel that has to be relatively airtight. We can measure the leakage in a vessel using a fan and a manometer, and the fan is going to be coupled with a calibrated orifice. The calibrated orifice is going to have a particular size. The manometer is going to recognize the sizes of the orifice there, and there may be a number of different sizes that we use that give us different ranges for various sizes of vessels and leakiness of vessels. Either we can have the orifice completely open, or we can have plates in here that make different sizes of orifice. But the important part to realize is it's a calibrated orifice, so that's going to help us measure. And there's also a fan sensor in there. So if we combine the information from the fan sensor and from how big the orifice is, the combination of those two can tell us either how many cubic feet per minute are going through the fan, or how many air changes per hour that the vessel is leaking at a particular pressure, or actually how big the leaks are. Any of those things can be measured by channel B. Now I think as we already discussed, channel A, we're measuring inside the vessel with reference to outside the vessel. We don't really need this tube, do we? Because this port is already open to the inside of the vessel. So we don't really need this tube. We do need this tube though, because this tube comes from the inside to the outside of the vessel, and that's the reference port of channel A. This is channel A right here, input port, reference port. We have the inside of the vessel with reference to the outside of the vessel. That's the measurement we're taking. A lot of times we're measuring things at 50 pascals. Then on the B channel, we're taking another pressure reading, and the pressure reading that we're taking is from the fan sensor. And so the fan sensor right here is giving us 200 pascals with reference to the area near the inlet of the fan. Okay, do we need this tube right here in this particular measurement? Think about it. No, we don't, because this port is already open, and we're basically always dividing the world into two places, the place that we're pressurizing and the place that we're depressurizing. We're just one zone with reference to the other zone. So we don't need this. But if we flip this around, we'd have to bring this tube to the outside, so it would be near the inlet of the fan. We have fan sensor with reference to the inlet of the fan. Channel A is vessel with reference to outside the vessel. Channel B is fan sensor with reference to the fan inlet. And that's basically how we measure the air tightness of a vessel.